To talk about solving quantitative problems, which is something we'll be doing quite a bit this year. In a quantitative problem, we are given a mathematical equation that contains variables that represent physical quantities that can be measured, and we are given measurements of some of these quantities from an experiment. And our goal is to calculate the value of a quantity that we don't know, which corresponds to one of the variables in the equation. There is a very specific way to go about solving these problems, and that's what we're going to talk about in this video. Okay? So, an example of a problem like this would be a sample of osmium has a mass of 56.9 grams and a volume of 2.52 cubic centimeters. Calculate the density of osmium. Steps. Number 1, analyze the problem. What are we given? What are we trying to find? Well, we're given the mass and volume of a sample of an element, and we're trying to find the density, so that means we'll need the equation that tells how density, mass, and volume are related to each other. Number 2, identify the missing variable and rearrange the equation algebraically to isolate the variable. Only after you have rearranged to isolate the variable you're trying to solve for should you plug in the values you're given with units. Perform the calculation on your calculator. Report your final answer with the correct unit, rounded to the correct number of significant figures, and then finally, go back and check your work. It never hurts simply to repeat the calculation just to make sure you didn't plug the numbers in incorrectly. So, let's do this problem. In this class, you do not need to memorize equations. You will be given them. I will give you the equation, density equals mass over volume. Because I'm given the mass and volume and I'm trying to find the density, I do not need to do any algebraic manipulation. It's fine as it is. But I do need to see the equation you're plugging in. I will plug in my 56.9 grams, divide that by my 2.52 cubic centimeters, and that gives me a value on my calculator of 22.579365, which I'm now going to round because I don't get that many sig figs. I go back and look at my initial measurements. Each had 3 significant figures. Because I am performing a division problem, I round to the fewest number of sig figs, which is 3. So I would report this result as my density is 22.6 grams per cubic centimeter. Okay? And it never hurts to draw a box around your final answer because then I know where to look for it. To obtain full credit on the problem, this applies the entire year, so make sure you fully understand this. You must show all of your work, which means you have to write the rearranged equation, show all of your values plugged in. You must include correct units in your work. You must include correct units on your final answer. And you must round your final answer to the correct number of significant figures. I won't take points off if you don't draw a box around it, but do yourself a favor and draw a box around it. Let's do a couple more examples. What mass of palladium has a volume of 54.90 milliliters? And by the way, I tell you that 1 milliliter equals 1 cubic centimeter by definition. Where would you find densities? Well, there is a really nice online periodic table, a variety of online periodic tables, or you can just use Wikipedia. I know your English and history teachers get upset when you use Wikipedia, but in chemistry it's perfectly fine. So I'll begin by writing down my equation. Density equals mass over volume. I am given the volume, and I look up the density, which is 12.023 grams per cubic centimeter, and I'm trying to find the mass. That means I need to rearrange algebraically to isolate mass. And I'll do that by multiplying both sides by volume. Volume then cancels, and I get my rearranged equation, mass equals volume times density. I need to see the rearranged equation that you're plugging into for you to get full credit. Now I'll plug in. My volume is 54.90 milliliters, which I'll convert to cubic centimeters by multiplying by 1 cubic centimeter over 1 milliliter. And then I'll multiply by the density, which is 12.023 grams per cubic centimeter. Let's check our unit cancellation. Milliliters cancel milliliters, cubic centimeters cancel cubic centimeters. We're left with grams, which is what we want. And I perform the calculation, and I get a value of 660.0627, which I will round to the correct number of significant figures, which appears to be 4. The volume had 4 significant figures. The conversion factor had unlimited significant figures because of the definition. The density had 5 sig figs, so rounding this to 4 significant figures, I get 660.1 grams as my final result. Okay? Now, I'm going to draw a big yellow box around everything that you have to include in order to get full credit. Okay? You have to include the rearranged equation. You have to show the work being plugged in. You don't have to show your intermediate value, but you do have to show your final answer with the correct number of sig figs. If you include everything that's inside the yellow box, you will get full credit. Let's do one more example. What volume is occupied by 806 grams of ruthenium? Well, I better go to the Wikipedia and look up the density, and I see that the density of ruthenium is 12.37 grams per cubic centimeter. I'm given the mass and I'm trying to find the volume. I'll start with my equation, density equals mass over volume. But before I plug in, I'm going to algebraically rearrange to isolate volume. I do this by multiplying both sides by volume, as I did before. So volume cancels volume, and that gives me mass equals volume times density. And now to get volume by itself, I divide both sides by density. Density cancels density, and I get my rearranged equation, which is volume equals mass over density. Now I can plug in my values. 806 grams divided by 12.37 grams per cubic centimeter. I perform the calculation on my calculator, and I get 65.1576. I go back, and I see that my mass had 3 significant figures, my density had 4. 3 is the fewest number of sig figs in the initial measurement, so I'll round this to 3 significant figures, and I get, as my final answer, my volume is 65.2 cubic centimeters. Once again, in order to get full credit, you have to include all of this. Okay, in our next video, we'll talk about graphing.